Hello everyone, welcome back. In today's video, we are diving into a topic called scheduling algorithm and multiple processor scheduling. So, as we already know about schedulers, process scheduling, so now it is the time to learn about those algorithms that do these types of scheduling. So, in today's video, we will understand what CPU scheduling is and why it matters. Then the different CPU scheduling algorithms and how scheduling works in multiprocessor system. So let's get started. Firstly, what is CPU scheduling? In a computer, the CPU is a limited resource and multiple process needs CPU time to execute. But since only one process can run at a time per core, the operating system decides which process gets CPU next. As you already know that the only one process can execute at a time. So how does the CPU decide? This decision making process is called CPU scheduling. Imagine a single checkout counter in a supermarket. The supermarket is very large, but there is only one checkout counter for the payment. Then the customers that are waiting in the line are the processes one by one. The cashier, or we can say the cashier is the CPU that serves one customer at a time because that is its capacity. Then the store manager decides who gets served next because the store manager will send the next person to the cashier to the CPU. So to ensure fairness and efficiency that each process gets CPU time fairly, we use different scheduling algorithms. So first come first, yeah, let us get started. The first algorithm that we would study is first come first serve. As the name suggests, it's like the process which come first will be executed first. The first process to arrive gets the CPU first. It is simple but not efficient for very short tasks. For example, a queue at a bus stop, first in line gets the bus first. It is very simple and easy to implement as we all know. But let us say there are some long processes that can delay shorter ones. For example, there is a process which is going to take 10 hour, but after that the another process is going to take just 10 minutes. So that CPU there will be a delay to the shorter ones. It is known as convoy effect. Then we have the shortest job next or shortest job first. It means that the smallest execution time of the process will get the CPU first. For example, there is a process with a execution time of 5 seconds and 10 seconds and 15 seconds. So the process with 5 seconds execution time will be get the CPU first. It does not matter whether it came first or last. It reduces waiting time but requires knowing process execution time of all the processes. For example, a restaurant kitchen. It prioritizes quick meals over slow cooking dishes so that it can serve at a faster rate. Now, the pros are the average waiting time is minimizes, but the longer processes may start. It will never get CPU time. So, what does it mean? It means that if there are 10 processes with 5 to 50 seconds, 5, 10, 15, 20, 25, and so on, but there is a process with 100 seconds. So, the the shortest processes will get execute first and the one with 100 will gets delayed. It will start indefinitely if there are shorter processes. So yeah, this is a very much disadvantage of shortest job first. Then we have priority scheduling. It means that each process is assigned a priority order and the CPU serves the highest priority process first. There will be priority based services and the one with the highest priority process will be served first. It can be both preemptive, that is, interrupts ongoing process, or non-preemptive. Then, for example, for emergency rooms in hospital, in hospitals, the one will critical patients, those who are critical, they will get treated first, and those who have checkups, they will wait. This means that the important task always run first. But there is a disadvantage also. The low priority process may start, not get CPU time. Yeah, like the example. For example, there is a low priority process in the number of processes. Then that process will not get CPU time until later. That is a disadvantage of priority scheduling. Then we have round robin. Round robin what? Each process gets a fixed time slot, time quantum in rotation one by one. If a process is not done, it goes back to the queue for another turn. It means that, example, a teacher giving equal time to each student during question and answer. For example, in a class, a teacher gives 10 minutes to each student. If that student is unable to finish their paper in that 10 minutes, then they will wait for another 10 minutes by going back, and then they will get another turn. It- the round robin ensures that all the processes gets a fair time. But there is a disadvantage also, because too small a time quantum equals to too many context switches, which slows down the execution time. Then, after this, we have multi-level queue scheduling. Multi-level queue scheduling, it means that the process are divided into separate queues based on priority, that is system and interactive batches or batch operating systems. We have learned about the types of operating systems in the very first lecture. So the processes are divided into separate queues based on priority on the type of operating system. Then the higher priority queues gets the CPU time first. In multi-level queue scheduling, there is priority. The high priority queues will get the CPU time first. For example, different service counters at a bank. VIP customers are served before regular customers because they are going to invest more and more, and then therefore they are a priority. One advantage of this are efficient for different type of processes. For let's say there are number of processes which there are different types, so we can use multi-level queue scheduling for their execution. But these all makes it very complex to manage. Then after that, these algorithms, we have multiprocessor scheduling. It means, as the name suggests, it means that there are multiple processes that are to be scheduled. In the most modern computers, they have multiple CPU or CPU cores. So, to maximize the performance, the operating system must schedule a process across multiple CPUs efficiently, because and also there are two main type of multiprocessor scheduling. The first one being asymmetric multiprocessing. It means that one CPU acts as the master and the others handle scheduling. The other CPUs execute tasks but do not make any scheduling decision. For example, a boss who is assigning tasks to its employees but making all the decisions. Like this, the CPU is the master or who is the boss, and he is assigning tasks to the CPUs to execute tasks but do not make any decisions that can affect the process. It is a very simple and avoids conflict since there is a one master. But the disadvantage is the master CPU can become a bottleneck. The master CPU will have too many processes at the same time. So that is a disadvantage of asymmetric multiprocessing. Going further, we will look at symmetric multiprocessing or SMP. In this, all CPUs share the scheduling load and make independent decisions. Most modern operating systems like Windows, Linux, and Mac OS uses SMP, symmetric multiprocessing. For example, a group of chefs in the restaurant, each chef can cook their own dish in by this, each chef can take up to a different task, and there will be number of tasks that are completed by the end. It is more efficient and no bottlenecks are involved since each process have their own task to complete. But it is very complex to implement. So we use a combination of both the multiprocessor scheduling, that is asymmetric multiprocessing and symmetric multiprocessing. So coming up, let us revise what we have learned so far. Firstly, we learned about CPU scheduling, that it is essential to manage the processes very efficiently. Then we learned about different scheduling algorithms like FCFS, first come, first serve, simple but slow for short jobs. Then the salt test job first. It is a very efficient, but those which longer jobs may starve indefinitely. Then we have the priority scheduling. It means that high priority task first, but there is a risk of starvation for the low priority task. Then round robin. It is fair, but with too many context switches. After that, we have multi-level queue or different. It means that different queues for different process types. After these algorithms, we learned about multiprocessor scheduling, in which we studied AMP. It means that asymptotic multiprocessor scheduling. One master makes the CPU make all the decisions. Then we have the symmetric multiprocessor scheduling. All the CPUs share the same workload so that not only one CPU gets overloaded. So I hope understanding these scheduling helps us how see how programs or the computers can run all the programs efficiently and in a better way. So if you found this video helpful, don't forget to like, subscribe and comment if you have any questions below. See you in the next video. Thank you.